Okay, exact values. So numbers that are exact, not approximate decimal values. So give me an example of an exact value. 4. Give me another one. 3. Okay, how about root 7? How about it? Pi. So, okay. If we just write the symbol pi, we're talking about it in its entirety, not writing just part of the decimal. So numbers that are exact, not approximated decimal values. So I already wrote root 7, look at that. Can include root 7 or radicals, but radicals must remain inside their radical to stay as an exact. If we can't square root it, we have to keep it that way. Okay. Fractions must be always reduced. So we can write a decimal as long as it would be so for example, let's go back up here. You could also say 0.3, okay? 0.3, just the decimal 0.3, is there any numbers after it? No, that's exact, okay? So we can write that, but if I have 1/3, I have to keep it as a fraction because I would be rounding or approximating it if I wrote it as 0.33 or 0.333 or whatever, right? So we want to keep it as a fraction. So you can only write a decimal if it's terminating. What does it mean to terminate? It stops at n, right? The terminator. You like n in life? Welcome to class. Okay. For angles 30, 40, and 60 degrees, we can determine their exact values of the trigonomic ratios. The easiest one, the first one, let's talk about a 45-degree triangle, right triangle. So the acute angle here is 45. Do we know what the other angle is? 45. So that's why if I make this side here, if we make this side a 1, this one is also 1 because it's an isosceles triangle. Because we have two angles equal, then we have two sides equal. Okay, using Pythagorean, why don't you solve for the hypotenuse? C squared equals A squared plus B squared. Square root of 2. And we want to leave it as an exact. You can't square root 2, so we're going to write it as just root 2. Okay. You want to memorize these two triangles. Okay? You're going to have to memorize them. Yay! Memorization. Okay, so now that we know that, tan of 40, let's figure out tan 45, cos 45, and sine of 45. Oops. All right, tan again. Yeah. Look how nice and bright that is. It's amazing. It's crazy.
There's a lot of new ones soon.
Okay. We'll figure something out.
Yeah, we might have to break all the rules and put it up ourselves. Okay. Or we won't tell anyone.
I'm good at that. I'm all about breaking the rules. Yeah. I'll do that.
I'll talk to Shelly and see if we can just borrow hers. Or you want to go back and forth in the library.
Right.
I don't think the library needs it.
They don't.
Except for like parent council meetings.
Yeah. Yeah. So she said just hold on to it until she requests it.
Okay. All right.
It's probably good for now.
Okay.
Yeah, thanks. Okay, so tan of 45 degrees. Oh, that was in the video. I love that when that happens. Oops. Oh well. Tan 45 degrees. Tan is what over what? Y over X. Y over X. Opposite over adjacent. Okay? So you can, if you want to use opposite adjacent, that's totally fine. So opposite of 45 degrees is 1. Adjacent would be 1. So 1 divided by 1? 1. Cool. Okay, cos of 45 degrees then would be 1 over root 2. Now, in this unit, is that okay? Yes. In the future, will that be okay? No. So in grade 12, you'll see it instead written as root 2 over 2. The reason why, if I multiply top and bottom by root 2, we get 1 times root 2. Root 2. What's root 2 times root 2? 2. Okay, so that's the same thing. Or root 2 over 2. Okay, last one, sine of 45. Opposite over hypotenuse. What's the opposite? 1 hypotenuse root 2, which is also root 2 over 2. Okay. All right, the next special triangle. So there's 2 special triangles. It's only 2 of them that you need to memorize. And that is the 30, 60, 90 triangle. Now, 3, 2, and 1 basically are numbers that we're going to throw in here. So the longest, we're dealing with 3, root 2, and 1. Oh, sorry, root 3, 2, and 1. Sorry. Erase. Root 3, 2, and 1. So those are the numbers we want to fill in here. Which one is the largest? Root 3, 2, or 1? What's the largest number? 2, right? If you actually punch in root 3, it's smaller than 2 because root 4 is 2. So it's smaller than 2. Opposite the largest side is the largest, or opposite the largest angle is the largest side. So 2 actually goes opposite the right angle. The opposite the smallest angle is the smallest side. So where's 1 going to go? The bottom. Good. And then root 3. Okay. So this is the 30, 60, 90 triangle. We probably use this triangle the most. So 3, 2, 1, as you can see. So let's figure out 2 sets of ratios. We're going to do sine 30, cos 30, and tan 30. We're also going to find the ratios for 60. What a difference that makes. Crazy. Okay. 30 degrees. So sine is opposite over hypotenuse, right? So we're just going to use SOHCAHTOA here, just because we're not drawing the 30 degrees as in standard position. Okay? So opposite over hypotenuse, what's the opposite to 30? 1 over 2, 1/2. You could check that. If you actually type in sine 30 degrees in your calculator, it should give you 0.5. Okay, if you type that in. Cos of 30 is adjacent over hypotenuse. Okay, what's the adjacent? Root 3 over 2. And tan is opposite over adjacent. 1 over root 3. Or if we rationalize this, we'd multiply top and bottom by root 3, and we get root 3 over 3. Okay. So again, I would accept this on your test, so you remember. Okay, sine of 60, so now let's look at 60 degrees. Opposite over hypotenuse, what's the opposite? Root 3 over 2. Cos of 60, cos is adjacent over hypotenuse. 1 over 2, and tan of 60, opposite over adjacent. Root 3 over 1. So just root 3. Okay. So these are the exact ratios for these angles. And they're going to pop up a lot, especially in grade 12. And so we need to memorize them. Okay. Yeah, it sucks. But if you just memorize this triangle here, And this triangle here, if you memorize that, if you know that, then you can figure out all these ratios just using SOHCAHTOA, right? So, yeah, it'll be practice. We'll practice it, but we do want to memorize these triangles. Okay, turn the page. Okay, so draw 30 degrees in each reference angle. Draw the following reference angles in each quadrant. Okay, so let's do that. What I'd like you to do is figure out each one of these angles. So I'll do the first one with you, and then you can do the other two. In the first quadrant, what would the angle be? 30, same as your reference. In the second quadrant, what would it be? My rotation angle would be 150. So 180 minus 30. Yeah. 180 minus 30. Okay, what would be the next one? Next rotation would be 180 plus 210. 180 plus 30. And then the last one, 330. 360 minus. Okay, so I'd like you to do the same thing for the other two. So 45. So 45s are right in the middle there. So if your reference angle was 45, figure out all the different angles. We check that you have the same values up above. So all of these angles, we can use our special triangles to figure out the ratio. Okay? Why? Because all of these have a reference of either 30, 45, or 60. And if you have a reference angle of either 30, 45, or 60, then we can use our special triangles to figure out the ratios as exact values. Remember when we type in a bunch of the ratios in our calculator, it would give us a decimal, right? So for example, if I type in, hello, where are you? Ah, there you are. Okay, so for example, if I actually type in cos of 120, okay, that one's okay, negative a half, but what if I did sine 120? Well, that one's going to give me a decimal, and I don't know the ratio as an exact value. But I know 120 has a reference angle of 60, and if I use my special triangle, I can figure out that that is actually root 3 over 2. Try that again. Let's try that again. Look how well you can see my calculator. Isn't that awesome? Root 3 over 2. Okay? And so now I know that 0.866, actually I can represent that as an exact value instead of a rounded decimal. And that's why we use our special triangles. So for these angles, whenever we see these angles, whoa, how many calculators do we have? Then we can use our special triangles. So for example, determine the exact ratio for 135 degrees. Let's start by drawing it. What quadrant? 2. Okay, we need to find its reference angle. What's the reference angle for 135? You might have seen it up above. What was it? 45 degrees. Okay, so the reference angle is 45. That means I'm going to draw my special triangle. We know the ratios for a 45 degrees. 1, 1, and what was the hypotenuse? Root 2. So now I can figure out each of the ratios. Now, what do I have to add? What did I not add in my picture? Something's missing. Because we're in quadrant 2. Ah, who's negative? X is negative, Y is positive. Okay, So now I can find the ratio for sine 135 as an exact value, cos 135, and tan 135. Oh, yeah, sure. No, let's just erase that. Tan 135. Okay, so let's start with, oh, my S got moved. Okay, let's start with sine. Sine is y over r, or opposite over hypotenuse, so what would that be? 1 over root 2, good. Cos 135, adjacent over hypotenuse, or x over r? What would it be? Negative 1 over root 2, and tan 135, opposite over adjacent. 1 over negative 1, so negative 1. Can you check your work? Yeah, easily. Really easily. I type in sine. I type in 135. Boom, it gives me 0.707. Then what else am I going to type in? 1 divided by root 2 should be the same thing. There it is. Cos 135. Yep. Negative 1 over root 2. Yep. And then tan 135. There it is. Cool? Sort of? I don't know. Eh. Okay. It's Friday, I know. You'd rather be doing a lot of other stuff. Let's try one more. Find the exact ratios for 150 degrees. So let's start drawing that. What quadrant? Man, so boring, eh? 2 again. Okay, what's the reference angle?
30.
The distance between the x-axis and our angle? 30. Okay, so if our reference angle is 30, we are going to draw the 30, 60, 90 triangle. So I'm going to go straight line. If this is 30, this is 60. Okay, so what I like to do, opposite of 60 is the root 3. 2 for hypotenuse, then 1. So opposite of 60, that's a 60. I don't know if you can tell. Not really, hey? That's a 60 there. So opposite of the 60 is always the root 3, then 2 for hypotenuse, 1. So that's what you need to memorize. What do we have to add that's not there yet? The negative sign for the x. X is negative. And now we can find sine of 150, cos of 150, and tan of 150. You will have to do this on your test or your quiz. Okie dokie. Sine of 150. So sine is what over what? Opposite over hypotenuse. So that would be 1 over 2. Cos of 150. Adjacent over hypotenuse. Negative root 3 over 2. And now tan, opposite over adjacent. 1 over negative root 3. If you want to rationalize that, you can. It'd be negative root 3 over 3. Normally, we put the negative on the numerator, but I will accept this answer. Okay? Could you check your work? Yes, quite easily. Okay. We're almost done. No, we're not. Darn it. Shoot. Do you want to skip example 4? Okay, good. Done. That took a lot of convincing. All right. Okay, your back side of your quiz on Tuesday is going to have questions like this, like 3 or 4 of them. So kind of important. So we can work backwards and use our special triangles to get our angles. But you can also use inverse. So I don't know. Okay, let's talk about this. Sine theta equals 0.5. So the first thing we want to talk about is cast. What does cast tell me? Quadrants. What quadrants will we be in? 1 and 2, because we have a positive ratio. Sine is positive in quadrants 1 and 2. Cool. Now, I mean, let's find our reference. How do we find our reference? What do? We did this yesterday. If you have a ratio, you want to find the angle. What did we do in grade 10? You had it. Inverse sine of the ratio. What does that give you? The answer? Only part of the answer. Remember, we always put the positive ratio in. Okay, because we want the reference angle, the acute angle. So if the ratio was negative, we would just inverse the positive. Okay, so do we know what our angles are? Quadrant 1. What would our theta be? 30, same as my reference. Quadrant 2, oh no, yeah, 2. What would be my angle? How'd you get that? 180 minus 30. So 180 minus the 30, so 150. So there's my answer, 30 and 150. Okay, and you could just type in cos of 30, cos of 150, it should equal to a half. That's how you check it. Okay, next one. Woo, interesting. What's different about this question? It's a fraction, yeah. What else? It's a negative, okay, so that tells me something. So normally if cos is negative, what quadrants would that be? S and T, except for what does it tell me about this question? If you read the rest of it. Our domain is we're just wanting between 0 and 180. So we're actually not including any of that part of our answer. We just want quadrant S, or 2. Yeah, we just want the second quadrant. So let's start by finding my reference angle. How would I find my reference angle? Inverse. Oops, that's not a sign. Cos inverse of, what would I type in? The positive ratio. Notice that's positive. So inverse cos of 3 over 2. Calculator. Nope, calculator. So we do that by going second cos root 3. Make sure you get out of the square root. So you might have to close the brackets depending on the type of calculator, or push the right arrow over 2. Okay, my reference angle is 30. Now you could have also used your special triangles to figure that out, right? Because you've seen root 3 over 2 before on a 30, 60, 90 triangle. So you could have also figured out your ratio because you know, okay, opposite the 60 is root 3 to 1. So you know, okay, when are we going to have adjacent over hypotenuse being root 3 over 2? That was if at 30 degrees. So you can also use your special triangles to figure out the reference, and you're going to do that in Math 30 a lot. But I mean, if you can use your calculator, why wouldn't you? Instead of using something you have to memorize. I would use my calculator, it's faster. So what's our solution? What's our angle? 150. 180 minus the 30. So 150 is our answer. Okay, let's just do example 2. 3 is no different. Well, maybe let's do 3. Let's skip 2. So what about approximate? I mean, the steps are the same. Determine theta to the nearest tenth of a degree given sine theta equals negative 0.0809 something. So again, we always start with cast, and we figure out which quadrants. So which quadrants would our sign be negative? A negative sign. 3 and 4. Okay, so we know quadrant 3 and quadrant 4. Then what do we do next? So first step is cast. What's the second step? Find our reference angle. And we find our reference angle by doing what? inverse. So inverse sine. And what do we always put in? Positive. Inverse of positive ratio. So let's answer, it says to the nearest tenth. So 1 decimal place. Inverse sine 0.8090. 8090. Oh. To 1 decimal place would be 54.0. That's boring. But once the nearest tenth, we have to answer to the 10th. Okay. So what's the third step? We found a reference angle. Now what? Fine. Now we can find the rotation angles. Whoa. Rotation. Yeah. Angles. And how many will there be? 2. Okay, so quadrant 3. How do we get it? If our ref 54.0. So 180 plus 54 is what? 234. What's the nearest tenth? So we're doing it. Okay, how do we find it in quadrant 4? 60 minus the reference, and that gives us 306.0. Where they are. There's our 2 angles. Okay. Could you check your work? Yes. Type in sine 234 should equal negative 8.8090. Type in sine of 306. It should also equal that ratio. So really, let me move this. Move. Okay. Sine 234, negative 8.8090, and then sine 306. Okay? All right. We got through it. I didn't know if it happened, but we did. And with time to spare. Okay. So what's the assignment for today? You would need to finish off yesterday's stuff if you haven't yet. I'm not sure if you actually did. There's a lot. Right? So the 2 assignments for yesterday. What's today's assignment? Page 88 to 89, right?
83 to 87.
80, so close. 83 to 87.
8, 11, and 13. On those pages.
8, 11, and 13. And then?
96. Page 96 to 99. Questions 2, 9, 18, and 29.
Okay, so that's today's assignment. If you haven't finished yesterday's stuff, you need to do that. So everything up to we've covered up to today is on the quiz on Tuesday. What we cover on Monday, not on the quiz. Okay?